What's up, scholars? Today we're going to talk about finding limits from a table, building off of what we talked about last time, which was finding limits from a graph. So let's get into it. Okay, so when we're talking about limits, we're talking about approaching some number. And we talked about last time approaching a number from the left. That's when we have this little minus sign next to the number we are approaching from. So this means approaching the value of 1 from the left. This is saying approaching from the left. And then if we had the plus sign over there, that means approaching the value from the right. Approaching from the right. Approaching from the right. Approaching the value of 1 from the right. All right, let's make that a little tinier. Box over here. Okay, great. Then this value here is not saying, so this says the limit of f of x as x approaches 1. So that's left and right. And this will only exist if the value we approach from the left is the same as the value we approach from the right. So this only exists if the value approaching from the left and from the right are the exact same number. Exists if the value we find approaching from the left and right are the exact same value. And then this last one, not a limit at all. That's just the value of the function at 1. The value of the function at 1. The value of the function at this given input or x value. You can have a limit as x approaches 1 that is different than the value of the function at 1. That is totally possible. So our notation, again, we have the limit as x approaches 1 from the left, the limit as x approaches 1 from the right, the limit as x approaches 1, which will only exist if the value we find approaching from the left and from the right are the exact same value. That means the limit exists. And then this notation here is what is the value of the function at the given input, in this case, 1. All right, cool. All right, so let's look at a delta math example. It says enter x values into the table below to determine the function values for a function for various inputs. Use these function values in order to determine the answers to the questions below. So we're going to find the limit of the function as it approaches x, or as x approaches 1 from the left, the limit of the function as x approaches 1 from the right, the limit of the function as x approaches 1, again, which will only exist if the previous two limits we find are the same number, and that is the limit overall for the function. And then what is the actual value of the function at 1? Okay, so I kind of want us to think of a number line here. And we are most interested in, looks like the value of 1. So I'm going to put that right here in the middle. And we'll be looking from the left, be over on this side first. So we want to plug in some numbers that are really close to 1, but they're less than. They're on the left side here. This is our from the left, AKA maybe we'll say this is as x approaches 1 from the left, and this will be as x approaches 1 from the right. Left and our right side. All right, great. Get my cursor back here for me. Cool. If we want values from the left, I want, again, numbers that are close to 1 but less than 1. So I could say 0.9. That's close to 1 but less than 1. All right, how about 0.99? Okay, that's even closer. How about this one? Okay, so I'm just going to put in like a ton of 9s. What do we get? This looks really close to -1. It seems to be approaching -1. Got it. Awesome. Now let's clear the table. Let's look at values from the right, which means we want values that are close to 1, but a little bit bigger than 1. So how about 1.01? That's pretty close to 1, but bigger than 1. How about 1.001? Okay. How about 1.0001? How about 1.000 with a ton of numbers here? That seems to be approaching -1 again, which means our limit as x approaches 1 does exist because our limit from the left and our limit from the right are the same number. So our value here is 1. And now what is the actual value for the function when x equals 1? We get -1. So in this case, the limit for the function as it approached 1 is the same as the value of the function when it actually is 1. Okay, cool. Let's submit our answer. Let's say yes. Let's say, give me that. Oh no, what happened? Some of you caught it, didn't you? We got the right answers. And what did I do? What did I do? Oh, so sad. I forgot my negative right there. Have to do this problem all over. The ideas were right. The answer was wrong. That is a bummer, but that is okay. Let's do another one. All right, come back for round 2. Feeling good, feeling great. Same idea, enter values, x values into the table to determine the function values for various inputs. Use the function values in order to determine the answers to each of the questions below. So now our number of interest is -4. So let me slap up a little number line here just to remind us what we're doing. We're going to look at approaching -4 from the left and from the right. So on this side, this is where x is approaching -4 from the left, and over here will be x approaching -4 from the right. So if I want values that are approaching -4 from the left, that means a little bit more negative than -4. So we're going to want things like -4 point, nope, more negative, right? More negative. Let's do -4.01. What do we get? All right, 3.82 something. Let's get a little bit closer to -4, but slightly more negative. -3.802. Got it. Let's put another 0 in there, -3.08002. Let's just put a bunch of zeros. Whole bunch of zeros. Let's try that out. Okay, 3.8. It's just telling me right there, as I get closer and closer to -4 from the left, we are approaching 3.8. Okay, so now let's approach -4 from the right. Making sure my negative values are correct. That's a positive. That should be a positive. I'm not making the same mistake again. I refuse. Je refuse. Okay, approaching -4 from the right means pretty close to -4, but slightly more positive. So how about 3.9? How about 3.99? Okay, I'm glad I plugged in a couple more things. So that changed somewhat dramatically. I mean, by 2/10. Let's put some more 9s in there. Ooh, this is looking familiar. 3.8, got it. So the limit as we approach -4 from the right is also 3.8, which means the limit for x approaching -4 does exist. It's the same number. Now, what is the actual value for the function at -4? Oh, look, it's 4. That's totally different than our limit, which is okay. That can happen sometimes. All right, you guys ready? Feeling good, feeling great. Much better, much better. Very good. Seeing all our answers. We did a great job. Fabulous. Okay, let's do another question. Same idea. This time our number of interest is -5. Let's look at approaching -5 from the left, so slightly more negative. So let's plug in -5.01. Let's try it. I get 90. All right, let's get a little closer. 900. Let's get even closer. 9,000. What? Let's plug in a bunch of numbers here. A huge number. What is happening? I wonder how many zeros it'll let me plug in. That was all of them. I think I plugged in all of them. Oh no, that's way more. Undefined. What do you mean undefined? Well, this is getting bigger and bigger and bigger and bigger as we get closer and closer and closer to -5 from the left. So things getting bigger and bigger and bigger in the positive direction means we are approaching infinity, the limit, as we approach -5 from the left. This number is getting bigger and bigger and bigger and bigger and bigger. It's going to keep growing forever. It means we are approaching infinity. Okay, interesting. Now let's look at what happens when we approach -5 from the right. So we want -4.9 close to -5, but it's a little bit more positive because we are coming from the right. -8.9. Interesting. Let's put another 9 in there. Oh, that's bigger negative by a factor of 10. Even bigger negative. Even bigger negative. Just throw a bunch of 9s in there. Make it the biggest negative I'm allowed. I'm betting. And undefined again. What's happening here? Well, this is getting more and more negative as we get closer and closer to -5 from the right. So we are approaching our limit as x approaches -5 from the right is negative infinity. Negative infinity, which means our limit for the value of x approaching -5, these two limits from the right and left weren't the same thing. So that means the limit does not exist. D and E, it does not exist. And what happens if I actually plug in -5? All right, got it. There must be an asymptote there. Yep, because as we approached -5 from the left, the values got bigger and bigger and bigger and bigger and bigger. As we approached, let's see if I can draw this on top of our values got bigger. As we approached from the right, our values got more negative, which to me would indicate some sort of asymptote at -5, meaning the function is undefined. It has no value at -5. All right, let's go get that big money. Let's submit our answer. Hey, all right, fabulous. All right, I want to talk about one more type of question where we are looking for the limits to infinity from a table. So we're going to enter values again, but we are trying to see what happens as x goes to negative infinity and x going to positive infinity. So on our number line, we're looking for the very, very ends of it. We're looking for the very ends, which of course don't really exist. Infinity is not really a number, it's a concept. But to figure out our limits here, we have to plug in actual numbers. So let's go in the negative infinity direction first. So let's plug in like a huge negative number. Where are we going? I'm getting a very large negative number, 24,211. How about a bigger negative number? Lots more zeros. Oh, overflow. Okay, I kind of lost me. I did too many. Let's try another one. What's happening? Oh, that's still overflowing. Oh, that's still overflowing. What do we think is happening here? That's the same one I had before. Will give me one more? One more? Yes, great. Okay. So we are going, it looks like negative, like very negative, like the most negative. We went from negative 24,000 to negative 3.5 times 10 to the 39. So we're going very negative. We're going very negative to the point where the calculator is overflowing. We must be going to a negative infinity. Negative infinity. All right. How about what happens as we try to go positive? Maybe I'll try not quite so crazy of numbers this time. If I plug in 100, I'm getting to negative 3.2, right? How about 1,000? Again, we're trying to go to positive infinity, so we want bigger positive numbers. Okay, negative 1.7. Got it. How about 10,000? Now we're at negative 0.5. Oh, that's a big number here. Oh, I wonder if that, that must be, that's our limit. As we approach positive infinity, as we get bigger and bigger numbers, we get to negative 0.5. And that's our answer. Because when we submit it, we get all the monies. All right. That's it, scholars. That is your whole lesson on finding limits from a table. That is your last lesson of this semester. Congratulations, you made it. Now all we have is that one last little hurdle, just a tiny little dibble of a thing, that final exam, which you're going to do great on because you're a bunch of champions. All right, I love you so much. Keep on that hustle. We're almost there.